All right, folks, let's do some more exponents. Today's just kind of an extension of yesterday. You gotta have that foldable out unless you have all of them memorized, all the different rules. I'll reference some of them, other ones we'll just kind of go over. The first part's all word problems, the next part's a little trickery. Anything to the zero power is 1. Done. Move on. Number 2, number 3, area and volume. Area of a triangle is 1/2 base times height. So the area of this guy is going to be 1/2, and our base is 2a cubed b to the 6th, and our height is a cubed times b. So 1/2 times 2 cancels out, and then it's just a matter of factoring, or not factoring, just combining. So a to the third times a to the third is not a to the ninth, it's a to the 6th. I got a little 1 right there, so then it's a to the 6th, b to the 7th. So that's it for that one. On number 3, we got volume. Volume of a cylinder is the area of the base times the height. And that's the area of the base, 5x to the 8th, y to the 3rd. So volume equals 5x to the 8th, y to the 3rd, times our height of our cylinder, 3x negative 2, y to the 0. So now we're just multiplying and combining. So 5 times 3 is 15. x8 negative 2, that makes x to the 6. Y to 3, y to 0. 3 plus 0 is just 3. Ready? Number 4 on here we're going to skip just because that doesn't really apply to what we're talking about right now. It's a great problem, great application. You would take the length, you take the width, and you take the height and you multiply that, and you're going to have to end up doing the FOIL and box method on that one, which is a great problem, but it's just not applicable to what we're doing as far as our exponent rules. So that's as far as I'm going to go for that one. On number 5, the area of a circle is pi r squared. Tells us our area is 4 pi x to the 8th y squared. So they both have a pi, so pi's are gone. Then I'm going to take the square root to get what r is. So square root of 4 is 2, and then we just cut both of those in half. So x to the 4th, and then y. Done. Number 6 kind of works the same way, working backwards. They tell us the area is 21 h to the 4th g f to the 0, and I want to figure out what the width is. I can just divide by the length. So divide by 7 h to the 3rd g f to the negative 2nd. 21 over 7 is 3. H to the 4th over h to the 3rd is just h. G's cancel out. Then if I have a negative 2 on bottom, because really this is gone, that moves to the top, so I got f squared. Alright, I think we got one more. No, we're done. Cool. Done with word problems. The next few are just, you gotta know this trick. The trick is that if we have the same bases, we can set the exponents equal to each other. So here, anytime you got a base times a base, we're going to end up adding. That was that first rule we learned yesterday. So now, since the base is the same, that means the exponents got to equal each other. So what times 7, or what plus 7 equals 5? Negative 2. So once we got that one rule, I think we're solid. Same thing here. We multiply power to a power. So 12 to the 5x equals 12 to the 100. So what times 5 gives us 100? X has got to be 20. All right, so that's really how all these work, is just manipulating some stuff around. Y's cancel out. Then I got 5 to the negative 2x equals 5 to the 5th. Well, all I want is to figure out what x is. So negative 2x equals 5. Because that's my other exponent there. So then I divide by negative 2, and x is negative 5/2, or if you want to go decimal route, negative 2.5. Okay, that's how all these work. Let's talk about number 10, and I'll probably do 11 too, and then kind of be done, because these are all fairly redundant. So on this one, I want to get the same base. Okay, I don't know what 32, there's a lot of options for 32 as far as multiplying goes. There's not many as far as having a base raised to an exponent. The one we're going to use, and pretty much the only one, is 2 to the 5th power. So 2 to the 5th power means 2 times 2 times 2 times 2, not 2 to the 16th. That would be 16 2's, and I do not want that. So now I can set the exponents equal to each other. So 2x plus 1 equals 5. Subtract 1. Now we're just doing a simple algebra 1 problem. So x is dos. Number 11. So 3 to the 4th power. 27 is the same thing as 3 to the 3rd. Got to be careful that I have this in the exponent there still. If I have an exponent raised to an exponent, I distribute. So that gives me 3x minus 3. Now I set the exponents equal to each other. 4 equals 3x minus 3. Be careful, we add 3 to both sides here. I get 7 equals 3x, divided by 3. It's a terrible 3. And x is 7/3. Alrighty? Good luck. We'll see you tomorrow. Bye.